Hello, this is Chemistry, the Central Science, 11th edition. We are in Chapter 4 on solutions, and this is number 19 and 21 from the end of the chapter questions. Number 19. Using solubility guidelines, predict whether each of the following compounds is soluble or insoluble in water. So I need my swimming pool. Let me go fetch it. Okay, so if you remember, anything in the pool is soluble, anything out of the pool is insoluble. So if you mix things together that is soluble, then it will be soluble in water. If it's on the outside, it will not be soluble in water. It's insoluble. All right, the first one is nickel chloride. All right, so chlorine is one of the kids on the side. This is group 7A, so this is chlorine, bromine, and iodine. All right, the swimming kids, and they are all soluble with the exception of lead, silver, and mercury. Well, this is not lead, not silver, not mercury, so it's going to be soluble. Okay, let's do B. Silver sulfide. Okay, silver sulfide. Sulfides are the rotten egg. All sulfides are insoluble, so silver sulfide will be insoluble. All right, let's look at number 3. Cesium phosphate. Okay, well, I don't see anything in the pool or out of the pool that's phosphates. Oh, yes, I do. Fozzie Bear. Phosphate is Fozzie Bear. That's insoluble, so cesium phosphate will be insoluble. Strontium carbonate. Okay, carbonate. Well, that's the coal. Carbon is coal. So carbonate is coal. It's insoluble. So strontium carbonate is also going to be insoluble. And the last one here is lead sulfate. Okay, so lead, this is sulfate. She's the yellow girl. Sulfates are soluble because she's in the pool, but these are the 6 exceptions to sulfates. Is lead one of the exceptions? Yes. That's a bullet. So lead sulfate is insoluble for that reason. Okay? Can you see how useful this is? I absolutely love this. I think it's very cool. Okay, number 21. Will precipitation occur when the following solutions are mixed? If so, write a balanced chemical equation for the reaction. All right, again, I need the swimming pool in order to know which are soluble. Anything that's soluble at the beginning and the end are be fine. Okay, anything that is insoluble will turn into making a product. So let's remind ourselves of what's in the pool. The alcohol guys are the alkali metals. So that's anything in group 1. Sodium, potassium, all of the strontium. Okay, those are the alkali metals. The guy with the heart, that's nitrates. The diaper is ammonium, NH4. The grumpy lady is acetate, C2H3O2. The yellow lady is sulfate, SO4. The kids are the group 7, so chlorine, chlorides, bromides, iodides. Okay, everything else is insoluble. So we're looking for sodium carbonate. Now, obviously, all of these are going to, at the beginning, are going to be soluble because carbonate, if you see carbonate here, it's coal, it's insoluble, but anything that's attached to it, sodium is an alkali metal, so it's always soluble, so sodium carbonate is soluble. Okay, so anything that's in the pool will be soluble. So silver nitrate is the heart attack guy, so it's soluble. So I want to see that if these two guys come back together, they're just going to break apart together again. If the silver and the nitrate, once they break apart, just come back together, they're going to break apart again. So if it's soluble, it dissolves. That's what soluble means. You put it in the water, it immediately breaks apart. Okay? What happens if I add the other two? So I add sodium and nitrates. Okay, do you see I've got the nitrate from the back, sodium from the front. Okay, what's going to happen to that? Well, sodium is an alkali metal. It's soluble. Nitrate is always soluble, so it's soluble. Okay, so that one will still be soluble. What about if I join the other two? So I have silver from the front of this one and carbonate from this, okay? Well, all carbonates are insoluble except for the ones that are in the pool. So silver carbonate would be insoluble. That means it is going to be a product, okay? So I'm going to need to put it together. So I'm going to say Na2CO3 plus silver nitrate, okay, yields, okay, silver carbonate, okay, it's a solid. This is going to be aqueous. This will be aqueous, okay, because it's dissolved in water. Aqueous means it's soluble, it's broken apart. But AgCO3 is solid, okay, it's a solid. And then the other one that we had was plus sodium nitrate, and it's aqueous. All right, so the only thing that's made is this guy. This is what's being made. You put the carbonate and the silver ions together, you get, or the carbonate and the silver, and you get silver carbonate. All right. Now, all I can do is do a few of these and see if eventually your brains catch on. That's the only way you can learn. So I'm going to do number B. All right. Well, number B, I've got sodium and nitrate. Sodium is in the pool, nitrate's in the pool, so it's soluble. Nickel sulfate, okay? Sulfates are all soluble. Nickel is not one of the exceptions, so these are soluble, okay? So we start with soluble. What are my possibilities? Now remember, if these come back together, once they break apart, if they come back together, they're just going to break up apart again. It's a junior high school romance, okay? No big deal. What's going to happen if the other partner joins up, okay? So I'm going to start with this one, sodium and sulfate, okay? Sodium and sulfate. Well, sulfates are all soluble, and sodium is not one of the exceptions. So this is going to be soluble. So this will be aqueous. That's one possibility. What's the other possibility? I take the first, which is the nickel, and I take the last from the other one, which is nitrate. Nickel nitrate, well, all nitrates are soluble, okay? So your answer for B is, the question was, will a precipitation occur? And B is going to be no, they will not occur, because at the end, both will be soluble. And if they're both soluble, you don't have a product, okay? So that was, for the question 1 would have been yes, or A would have been yes. It was, did have a product because you had an insoluble, one of the things were insoluble, and then we did the formula to show you, their balanced equation to show you. Okay, here's the last one. We have iron sulfate. Well, sulfates are all soluble. Iron is not one of the exceptions, so it is soluble. Lead nitrates, all the nitrates are soluble, so both of these are soluble. So if they come back, once they break apart, that's what soluble means, they dissolve. If they were to come back together, they would just break up again. If they ever came back together, they would just break up again. What if the other one flips, okay? And iron doesn't join with sulfate, but it joins, this is iron 2, would join with nitrate, okay? Well, what happens? All nitrates are soluble, so this one is going to be soluble, so this would be aqueous. Okay, so it's not going to form anything, that one. What's your other option? Your other option is to start with a lead, and then put in, it's a lead 2, and it joins up with a lead sulfate. Okay, so lead sulfate, here's sulfate, it's soluble, but lead is one of the exceptions, so that means it's insoluble, okay, which would be solid. So I need to do a balanced equation. So I'm going to write what we start with, FeSO4 plus PbNO3 yields. Okay, so those are my two salts that I put together. Put them in water, put them together. They break apart, and if they join back, they just break apart again. But if they switch partners, then you're going to end up with lead sulfate, which is a solid, plus the other partner was aqueous, was iron 2 nitrate aqueous. Okay, so this is aqueous, and this is solid, and this would be the answer for 4C. Okay, so not easy, but I think you can do this. I think you would, if you could practice this, I think you could do it. Thank you.